Okay, we have a problem where we want to find the line of intersection between these two planes. Now, what do we know? We know unless the two planes are parallel, unless they have normal vectors whose dot product is equal to the product of their magnitude, or whose cross product is 0, and since we're going to end up doing the cross product of normal vectors, that's a test you would use. If the cross product of the two vectors is not 0, that means that these vectors, that the normal vectors are not parallel. It means that the planes will then intersect. Now, if they're parallel, it's possible that the two planes intersect, but if they do, since they're parallel, they intersect everywhere. So every point on either plane is a solution. In either case, you're not going to get a line. If the planes are parallel but don't intersect, they don't intersect. There's no line of intersection. If they intersect completely, then you have infinitely many lines of intersection. You don't have a unique one. Okay, any line in the plane will in fact be a line of intersection. Any line in the common plane. Okay. Well, in this case, here are normal vectors, okay? And we can see right away that the components of this vector are not a constant multiples of components of this one. It came out close. If I'd have had a 4, 4, 4 here, and if that hadn't been a negative, then they would have been parallel, wouldn't they? Okay? And that can happen. The random number generator just picks random numbers between -3 or -4 and 4. And if every one of these numbers is the same multiple of every one of these numbers, it could happen. It wouldn't be likely, but it could happen. So, anyhow, the cross product is parallel then to both planes. Okay? So that means that the cross product is parallel to the line of intersection. Now I could show you how to calculate the cross product, but you can do that. There's no point in my working through that detail, at least not in this case. Okay? Now the other part is you need a point common to both planes. Okay? How do you find a point common to both planes? You have to have some point where these planes intersect. Well, we can eliminate one variable between these two equations. And if you look at the equations, it's really easy to eliminate x. You just add the two equations and you get the equation 7y and 7z equals what? 8 and -3, 5. Right there it is. 7y plus 7z equals 5. Okay? Now that's not a line of intersection. Actually, you know, could be a line of intersection in the YZ plane. Now that's not going to, and okay, yeah, we could go with that. But let's now pick a value for z. Okay, if we let z equal 0, then we get y equals 5/7. Okay, if y equals 5/7, then what's the value of x? Well, if y equals 5/7 and z equals 0, which is where we got the 5/7, then we know that x has to equal whatever we get when we plug 5/7 for y and 0 for z into either equation. And well, we plug into this equation, we get this coordinate for x. Had we plugged into this one and done everything right, and I think we did, we would have gotten the same thing. I'm not going to work that out to see. You should, though. Okay? So now we have the point -41 over 21, 5/7, 0. So we have the point zero and the vector the direction of our line of intersection, because this is a point of intersection, this is somewhere on our line of intersection, if it's a point of intersection, because the intersection does form a line. The direction of the line is the direction of the cross product. And then our equation of the line, it's going to be a vector to this point from the origin plus t times a cross product vector. Or if you want, t times a unit vector in the direction of the cross product, it doesn't matter. And we've seen that before. I don't want to do that cross product, so I'm not going to actually write the thing down. But let me depict it. Okay, here's a coordinate system, and let's take our point. Negative 41 over 21, 5/7, 0. It's going to be in the negative. It's going to be in the positive. It's going to be 0. So that's going to be about negative 3, and that's going to be a fraction. So it's going to maybe be a point like right here, where the projection on the x-axis is negative 41 over 21, about negative 2, and the projection on the y is 5/7, somewhat less than 1. Okay, then we've got a line, and the line's parallel to the cross product of these two vectors. Okay, now I'm not going to attempt to figure out where the cross product of those vectors is, although that wouldn't be particularly difficult. But let's just say now that the cross product is like this. And let's call this the cross product of the normal vector. So let's call this V equals N1. I wrote plus, need to write cross product with N2. Now we have a vector from the origin out to this point of intersection that we found, and this vector is negative 41 over 21I plus 5/7 j. That's a vector from the origin out to our point of intersection. Now we have our vector, our cross product of the two normal vectors, and now we have a third vector out to this point, and I'm going to have to modify this a little. I want this to be some number t times the normal vector, which will make it t times n1 cross n2. Okay, so let me write that just a little more clearly. TV equals t n1 cross n2. That's what I attempted to write down there. Hopefully that's a little more legible. Okay, so this vector, of course, is the sum of this vector and this vector, and the point at the end of this vector has to lie on our line, because our line goes through this point and it's parallel to the v vector, and TV is parallel to the t vector. So now we have then negative 41I plus 5/7 j plus t times n1 cross n2, whatever that is. Okay, and that equals xi plus yj, probably plus a zk. ZK is written there, but you can't see it. You probably can't read the YJ either. I can't. So let me write that a little more clearly up here. I don't think I'll need any more of this space. Negative 41 over 21I plus 5/7 J plus T times N1 cross N2 equals X of Ty plus Y of Tj plus Z of Tk. Okay. Now whatever your N1 cross N2 comes out, it's going to be a number times I plus a number times J plus a number times K. So when you multiply it by T, your I component is going to be a function of T, and we're going to call that X of T. That's the coordinate of the point on this line. The Y of T is a coordinate, the Z of T is the coordinate. If you have that conceptual framework, if you see this line as being traced out by this blue vector, which is the sum of some vector to a point from the origin to a point on the line, plus T times the product, the cross product of your two normal vectors, which is going to be parallel to your line because it's perpendicular to both planes, then you have a picture of how you get the parametric equations of the line rather than a bunch of disconnected steps that you don't really see as part of one single premise of one single whole. So hopefully you'll understand it on this level.